So what we're going to look at in this video is we're going to talk about how to construct what is known as a perpendicular bisector to a line segment. So first, what I want you to do is I want you to go ahead and look at the launch activity, try to see if you can come up with an answer, and then we'll go over it. So take a second to pause the video and look at the launch. All right, so one second. So let's take a second to look at the launch activity. Sorry, my stylus stopped working there for a second. Drew and Leroy are training for a marathon. They want to run together but live 1.5 miles apart. Where could they meet to make sure they run the same number of miles today? So we have Drew and Leroy right here. Say it's 1.5 miles apart. So Drew, Leroy, and so in order for them to meet somewhere and run the same number of miles, what they would need to do is they could meet here at the midpoint where they both run the same number of miles to get there. So they could meet at their midpoint between the two houses, or they could also meet somewhere else where, for instance, right here where they each run to this point that is equidistant away from their houses. So they could choose a point that is an equal distance from each of their houses and meet there. So we'll just call that for now a point that is equidistant from their houses. And we're actually going to talk about how to find that type of point today. So a point equidistant from their houses. So before we get started, we do need to talk about a few vocab words. So the first vocabulary word we have is a segment bisector. Okay. So what you need to know about a segment bisector is it's a line, ray, or segment that passes through the midpoint of a line segment. And the other important piece of information that you want to make sure you take away from this is that each segment has exactly one midpoint. Okay, so there's only one segment bisector because each segment that you might be working with only has one midpoint. So if you look over here at this example, you'll see that line L and M and N bisect AB. So L passes through the midpoint and cuts A and B into two pieces. So does line N, and so does line M. All three of those lines are segment bisectors. Notice they all pass through the same exact point because a segment only has one midpoint. But then if you come down to the next example that we have here, the next vocabulary word, we have a perpendicular bisector. Okay. Now, some things that you want to know about perpendicular bisectors. A line segment has many perpendiculars and many, okay. But a line segment is going to have many perpendicular lines. Okay. But in a plane, let me re-highlight this. So a segment has many perpendicular lines that cross through it. But in a plane, each segment has one bisector that is also perpendicular to the segment. So what that means is, while you look at this picture over here, you'll see that line J, line L, and line K are all perpendicular to line segment AD. Why do we know that? Because we know perpendicular lines intersect at 90 degrees. We learned that in chapter 1. But the only line that is a perpendicular bisector in this case would be could be possibly L if we knew that AO. So if we know AO is congruent to OB, then we would know that line L was the perpendicular bisector. But in this case here, it doesn't necessarily tell us if it's congruent, so we can't actually say if it's a perpendicular bisector. However, if we have this over here where we have line segment AB with line L being perpendicular to it, and it shows us that it bisects that line segment, then we can call that a perpendicular bisector. So what we're going to look at today is we're going to talk about how do we find the perpendicular bisector of any line segment. And so there's two investigations that we're going to look at. The first investigation requires us to use patty paper. However, since we don't have patty paper available to us right now, I went ahead and put pictures here that we're going to talk about. So the first thing that we would do is we would take our patty paper, we would draw a line segment on that patty paper. After we draw that line segment, we would label it PQ, and then we would fold our patty paper so that the endpoint P and Q are on top of each other. Okay, and so this vocab word that we have when you fold something and you have, in this case, two endpoints fall on top of each other, that is called, that we say that those two endpoints coincide, and that's where the endpoints P and Q land exactly on top of each other. All right, so we fold it, we crease our paper, we unfold our paper, and then we draw a line on the crease. And so what you'll see is this paper would have creased right along this line right here. So we draw on that line. Now, the next thing that we want to look at is we want to see what's the relationship of this line to PQ. So if we were to do this activity and we were to measure these, if we were to measure this side from P to, let's call this, we'll call it L, and L to Q. If you were to measure these two line segments, you would find out that these line segments are congruent. So what we find out about this line that we just drew is that it bisects this line segment. Now, if we were to take a protractor like we would in class, if we were doing this with patty paper and actually looking at this, we would see that this angle is a 90-degree angle, which would mean that this angle is a 90-degree angle. And as soon as we know that these angles are 90 degrees, well, that means that we know that this line, we'll call this line L, we would know line L is, I don't know why I put the L in cursive, but line L is perpendicular to line segment AB in this case. Okay, so if we did that with every group, if we had every group create a different line segment and do this exact same process, we would find out that everyone's lines would be intersecting at 90 degrees and everyone's line segment would be bisected. So it says, how would you describe the relationship of the points on the perpendicular bisector to the endpoints of the bisected segment? So here's what this is asking. If we take any points on the perpendicular bisector, so if we come over here and we look at this picture here, so we have the exact same picture that we had just up there, and except this time I put down 3 points on that perpendicular bisector. So what we would then want to do is we'd want to measure the distance from P to A and from A to Q. And what we would find out is that that distance would be congruent. And then if we took, if we measured the distance from point P to point B, and then we measured the distance from B to Q, we would find out that the distance for those two line segments would be congruent. And then finally, if we were to do this again and keep doing this, we'll do one more example. If we measured from Q to C, and if we measured from P to C, what we would notice is that those two line segments would also be congruent. And so what we find out then is we can come up with this perpendicular bisector conjecture. And what it says is if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints. So what that means is if you put a point on the perpendicular bisector, that no matter where that point is on that perpendicular bisector, it is going to be the same distance from both of the endpoints of the original line segment. So what we're going to do here is we're going to take a second to look at how to construct a perpendicular bisector with a compass. So we're going to switch over to the smart board so that we can use a compass on the screen. So what we're going to do is we are going to come over here, and it would be beneficial for you to follow along and do this at the same time on a separate sheet of paper, or if you've printed out this part of the notes, that is beneficial as well. So what we're going to actually look at here is what we're going to look at the converse of the perpendicular bisector conjecture. So the question that we would want to be answering is, if a point is equidistant or the same distance from two endpoints of a line segment in a plane, will it be on the segment's perpendicular bisector? So here's what we're going to do. You need to create a line segment on your paper. And then you're going to take your compass and you're going to take the pointy end and you're going to put it on one of the endpoints. And then you're going to take your pencil end of your compass and you're going to drag it out and extend it so that it is a little more than half of the length of your line segment. And then what you're going to do is you're going to take this and you're going to draw an arc. So what you're going to do, you're going to keep the pointy end on that end point of your line segment you drew, and you're just going to take your compass and you're just going to draw an arc right here. Okay, it doesn't have to be. You just want to make sure it's a decent length of the arc. And then what you're going to do is you're going to take your compass and you're going to move it to the other end point. You're going to flip your pencil over. You're going to keep the compass at the same length that you have it at. So you can see on mine I have it at whatever 229 means, but I'm going to keep it there. And then I'm going to flip my compass and we're going to make sure our pointy end is on the end point of our line segment. We're going to then draw another arc right here. Okay. Now, what we know is that this point where these two lines intersect, this means that at that point that I'm putting right there is the same distance from this endpoint. So we'll call this endpoint right here, we'll call that A. And again, it's hard to write with the trackpad on a, oops, let's do this. Let me move this compass real quick. So I forgot to label this, so we need to label it. So again, what we did, we took our line segment that we created and we took our compass and we made we put the compass on one end of the line segment and we then expanded or widened our compass to be about a little more than half the length of our line segment. So what we're going to do after we create those two arcs is we actually need to go over here on the other side of our line segment and we need to create a, we're going to keep the compass at the same length. We're going to then put the pointy end on one side of the line segment, so on line or endpoint A, and then we're going to draw another arc right here. And then we're going to take our compass, we're going to move it over to the other endpoint, again keeping our compass at the same length. We're not going to do any adjustment on that. We're going to then draw another line segment right here. And what we'll see is I'm going to move the compass out of the way now because we're done with it at this point, is we see that we get another two intersecting arcs similarly to what we had up there. And we know that this point right here is going to be equidistant from A and B. So now what we're going to do is we're going to connect those 2 points with a line. So I know I say a line here, I'm just going to use a line segment so that it doesn't go over all the other words on here. So I'm going to connect these 2 points. There we go. And we'll go ahead and expand this a little bit. There we go. And now what we want to do is we want to see, okay, well, what's going on here? What did we just create? And if we pull out a protractor, what we'll see here is we will see that we have, messing up the protractor here. We'll drag this down here. So first of all, is this line perpendicular to the line segment we had? And if we look at it, the answer is yes. It creates a 90-degree angle right there. The line that we drew in from the arcs creates a 90-degree angle with line segment AB. And then the other thing that we would want to do, let's get rid of the protractor and see, we have a ruler here. So let's see what happens. If we bring this ruler down here, let's measure the distance of each piece from A to the middle here. So from A to the middle, it's about 5.5. And then if we take our ruler over here and put that, you'll see that again it's about 5.5. So what we got here is we have a perpendicular bisector. This segment is congruent to this segment. So that is how you're going to go about creating perpendicular bisectors. So if we jump back over to the iPad, you'll see it says complete the conjecture below and write a summary of what you did in this investigation. So it says if a point is equidistant from the endpoints of a segment, then it is on, and in this case it is on the perpendicular bisector. Okay, and we want to summarize sort of what we did here to create a perpendicular bisector. So we'll summarize that right here underneath number 3. So the first thing when you want to create a perpendicular bisector is place compass on one endpoint of line segment and make compass a little more than half of the line segment. 2, make an arc from one endpoint and then an arc from other endpoint. 3, repeat on other side of line segment. And then finally, 4, connect intersecting, or connect the intersections of the arc of the arcs. And you'll get some more work doing this in the homework. Now, so what we have looked at is what we should notice here is that when you construct a perpendicular bisector, it's really nice because it also locates the midpoint of a line segment. Now that we know how to create or construct a perpendicular bisector and the midpoint, then what we were able to do is we're actually able to create different shapes, rectangles, squares, and right triangles. And then we can also, when we're dealing with triangles, create or construct two special segments in any triangle, the median and the mid segment. So you're going to get some practice creating these in your homework, but just so you know what each of these are. So the segment connecting the vertex of a triangle to the midpoint of its opposite side is a median. All triangles have 3 midpoints and 3 vertices, so every triangle has 3 medians. So if you look at this, the median connects a vertex and the opposite side, and it divides that opposite side into congruent sections. So it bisects the opposite side. A mid-segment is the segment that connects the midpoints of two sides of a triangle. So if you find the midpoint of two sides of a triangle and then connect them, then that gives you your mid-segment. So the other thing to know is a triangle has 3 sides. Each one has its own midpoint. So there are 3 mid-segments in every triangle. You are going to explore the median and mid-segments of triangles in your homework, and then we will talk about those in class the next day. So you're going to work on your homework for section 3.2 now, and then if you have any questions, message me on Remind or through email.